And welcome to the presentation on calculating molar mass of various compounds, both ionic and molecular. I think that we have a pretty good understanding of this topic as a whole, but in this video I just want to do a few brief examples just to reaffirm our assurance that we actually do know what we're doing, so when we get to the test we won't be completely clueless. Okay, so if you look on your worksheet, I'd like to take a look at number 13, because I think that 1 through 12, for the most part, on the second half of the worksheet, is pretty self-explanatory. If you have any questions about that, you could ask me in person if you want. But taking a look at 13, 14, 15, they're a bit more complex. So if we take a look at 13, we are given the formula Na3PO4, and we are asked to identify the number of each type of atom or ion in each formula or molecular compound, depending on which one it is, and then calculate the collective molar mass for the compound. So hopefully, if you haven't forgotten your polyatomic ions, you should recognize that we have sodium ions and phosphate ions present within this formula over here. If we're asked to describe the quantity of each type of ion, in this case, we would say that we have, as indicated by this subscript over here, or yeah, rather a subscript, we have 3 sodium ions, and we also know that we have some amount of phosphate ions present. You might be tempted to say that we have 4 of phosphate ions. That's not actually technically correct. Hopefully you remember that PO4 indicates the formula unit for this entire polyatomic ion. Because there are no parentheses, we say that we have 1 of that entire ion. Now, if we're asked to find the molar mass of this entire formula unit, in this case, we have to essentially break apart the formula, as I just did, and then add together, sum together the individual masses of all the ions that are present within this. So, if you look on your periodic table, you know that each sodium has a mass of, or molar mass of 22.99 grams per mole. And again, we have 3 of these. We're going to multiply this entire quantity by 3. Then we're going to add this to the collective molar mass of the 1 phosphate ion that we have here. Now, the phosphate ion is composed of of 1 phosphate, or rather phosphorus ion, and 4 oxide ions. So we know that each phosphorus, or rather phosphide ion, has a molar mass, if you look on your periodic table, of 31.06 grams per mole. And then we have 4 oxygens. We know that each oxygen has a molar mass of 15.999 grams per mole. And if we multiply that by 4, as we've seen here, because we have 4 of the oxide ions within this problem, we would get a quantity of 63.996, roughly, grams per mole. And if you perform the arithmetic operation, you would hopefully get a result of 163.94 grams per mole, which is exactly the answer that we were looking for in this case. Now, going on to number 14, I think this one's pretty straightforward as well. We are given the formula H2SO4. And again, this is technically an acid, but we have to recognize that acids are also ionic compounds, so we're going to be dealing with different types of ions in this. As we can see, hopefully, again, you remember all of this is starting to come back to you by now. We have hydrogen ions as well as sulfate ions present within this. So we know that we have hydrogen ions as well as sulfate ions. And as seen up here, this is, again, pretty straightforward, self-explanatory. We have 2 hydrogen ions. And because there are no parentheses surrounding this entire polyatomic ion, we have 1 sulfate ion. So now, again, we're just going to sum together or add together the individual molar masses of each one of the components of this formula unit over here. We know that, hopefully, you can just look on your periodic table and ascertain this. We have 2 hydrogen ions. Each one has a mass of 1.008 grams per mole. And we multiply this by 2 because we have 2 hydrogen ions over here. And then we have to add this to whatever molar mass there is of this sulfate ion over here. We know that we only have 1 sulfate ion, but that polyatomic ion is actually composed of 1 sulfide ion and 4 oxide ions. If you look on your periodic table, sulfur has a molecular mass of 32.06 grams per mole. Then we add this to 4 times 15.999 because each oxygen has a molar mass of 15.999, giving us a result of 63.996 grams per mole. If you do the arithmetic operation, which hopefully you do, you would get a collective molar mass as a whole of 98.07 grams per mole. And again, you could fact check that. That is exactly the answer that we were looking for in this instance. Finally, if we're going on to 15, we know that we're given K2SO4. Again, break this down to a cation and an anion because this is a formula unit. This is an ionic compound. So now, in terms of potassium ions, I have 2 of these. That's seen by the subscript 2 next to the K. And again, we are also dealing with sulfate ions in this instance, makes it very convenient for us. Because there are no parentheses, we know that we have one entire polyatomic sulfate ion. So we could write 1. And again, when we're trying to figure out what the molar mass is, we know that each potassium ion has a molar mass of 39.098 grams per mole. Again, we have 2 of these, so it's important to multiply by 2. Then we add this to the quantity of essentially 1 sulfide ion's molar mass plus the collective molar mass of 4 oxide ions, in this instance. So each sulfur, or sulfide in this instance, has a molar mass of 32.06 grams per mole. And again, we have 4 oxygens, which, as we saw up here, multiplied out to a value of 36.996 grams per mole. And again, it's pretty simple. If you do the arithmetic operation, you should get somewhere in the neighborhood of 174.25 grams per mole. Alright, and we're done. Again, if you just apply this logic to each and every single one of the problems on this worksheet, I'm confident that you'll have absolutely no problem at all. These problems are very simple. We'll get into some harder stuff later on. We'll get into limiting factors and other things that appear in this chapter. But for now, I would just work on strengthening these skills and make sure that you have a pretty good fundamental understanding of this. And good luck with it all.